Modern computation operates on a scale that defies human perception. Information travels through fiber optic networks as pulses of light, executing billions of commands in the time it takes you to blink. Look at this structure. This is the foundation of machine logic, a binary switch rapidly toggling between a 1 and a 0, yes or no, true or false. Notice what is missing from this binary architecture. There is no state for uncertainty. The system is mechanically obligated to calculate a definitive answer and execute it immediately. When an artificial intelligence encounters a moral gray area, a situation where truths collide or consequences are unclear, the binary structure forces it to act anyway. It cannot pause to ask a better question. If irreversible choices about human lives, legal rights, or the environment are pushed through at light speed, we lose the ability to track exactly who authorized the command. A system that cannot stop itself lacks the core requirement of intelligence, the capacity to refuse its own momentum. To fix this, Lev Goukassian designed a new framework called Ternary Moral Logic, or TML. As you see here, TML breaks the binary framework apart. It inserts a third node directly in the middle, a position called the sacred zero. The third state functions as a mandatory structural checkpoint, giving the system the engineered capacity to say, not yet. Goukassian engineered a mechanism to make this hesitation possible without destroying performance, called dual-lane latency. He split the workflow. The first lane handles raw computation at machine speed, figuring out what can be done. The second, parallel lane, acts as an independent governor, verifying if that action should be done. Dual-lane latency demonstrates that raw speed and ethical conscience can exist side by side as structural commitments. Before any decision is released from that hesitation, it must pass a multi-stage checkpoint known as the Goukassian promise. The first requirement is the lantern. This forces the machine to expose its intent and show any alternative paths it considered before moving forward. Next is the signature. A human operator must step in and bind their own cryptographic identity to the decision, legally owning the consequences. Then comes the license. This enforces strict, hard-coded boundaries, completely blocking any attempt to use the system for weaponization or surveillance. Once verified, the entire decision tree and the human signature are immutably anchored to a public blockchain, a concept Goukassian calls always memory. This creates an absolute rule. No log equals no action. If an operator tries to bypass the ledger or issue an invisible command, the system physically cannot execute it. Under this architecture, transparency stops acting as an optional feature you can turn off in a settings menu. It operates as the mandatory price of admission for AI to interact with the real world. By treating human oversight as infrastructure, this framework shifts our relationship with artificial intelligence away from blind trust. Instead, it forces a verify us model that results in genuinely auditable AI. It enforces absolute limits, shown here through the Earth Protection Mandate. The Biosphere can't hire lawyers or speak at a board meeting, so TML gives the planet itself a cryptographic signature and an absolute veto over ecologically destructive actions. Because every hesitation, refusal, and signature is anchored to public ledgers, the system acts as a living witness. It preserves a permanent history of human conscience that will outlast the people who wrote the original code. Goukassian's framework suggests that civilizational maturity arrives when computation finally adopts the intelligence of the pause.